Welcome to Frequency Matters, the RF and Microwave Update. I'm Pat Hindle, here with my co-host Gary Lerude and special guests Walt Strickler and Matt Diessner from Wireless Telecom Group. We're here at IMS2018, where the theme is mobility, medicine, and microwaves. So they added in a microwave biomedical conference, and they also had the 5G summit. So 5G was the word of the day and the word of the week. And for Wireless Telecom Group, you guys made an announcement to some improvements to your power sensor. Can you tell us about those?
Yeah, we have real-time power sensors, and they're really great for 5G applications. And a couple of the main reasons are, we have the widest video bandwidth of any sensor on the market, 195 megahertz. And so for 5G, you need 100 megahertz channels typically, and we're the only sensor that can do it. So we're showing that off in our booth. In addition to that, with the real-time power processing, we don't have any gaps in our measurement capability. And so as people are making measurements at 28 and 39 also for 5G, it allows them to really characterize their amplifiers. Since it's a higher frequency, there's less experience in a lot of the engineers we see. So having the ability to do it real time and really see what's going on with their amplifier and have the wide bandwidth so they can use it with a modulated signal allows them to really get a good characterization of what's going on with their devices. So we're finding a lot of interest from the people coming by and our customers.
Yeah, Matt, when I came by, you were doing some 5G analysis, OTA measurements, MIMO that you're using with the power sensor, and also some noise sources.
Yes, one of the things that we'd like to do is practical demos. And we are showing an over-the-air demonstration with Vivaldi antennas, and we're comparing our readings against the spectrum analyzer. And what we're finding out is that we're actually doing my favorite topic, as you know, is crest factor, peak to average power. And we are able to compare this readings to the spectrum analyzer. So we're using the noise source as a calibration for chambers from our noise group. We can calibrate the chambers, we can do over-the-air path loss. We have the ability to go to 45 gigahertz in our frequency generation with very high crest factors of about 10. So then we use this and compare the solutions to the spectrum analyzer. As you increase your input to the amplifiers, people are doing average power measurements, and what we're finding out, since these devices are going to be OFDM modulated, that we are seeing a compression of the peak power. Thereby, a power sensor using the bandwidth, the measurement speed, can be a nice supplement to the VNAs and spectrum analyzers. And using the noise sources, we can get up to 45 gigahertz, and we can really help our experience at 45 gigahertz and above is spectacular.
Yeah, we can actually go to 110, so
yes.
People doing backhaul for 5G or 802.11 AD, wide gig timing applications, this is a good device for them as well.
And how does the cost compare to another system?
Well, our sensors are value priced. For the performance, they're under $7,000 US.
And relative to a spectrum analyzer or VNA, obviously it's a much lower
huge
cost.
Difference, yeah.
Huge difference.
So you've talked about the commercial applications, communications, 5G. How about aerospace and defense applications?
Well, we recently introduced our 4500C, which is the peak power analyzer, which is really our flagship product. And it also now has the real-time power processing that we talked about. So in aerospace and defense, when you have long pulse strains,
right.
You could have dropouts or droop over that time. And having the real-time power processing allows you to monitor continuously over that time to look for anomalies again that may happen there. The other thing is, because it's real-time and has up to 10 gigasamples per second effective sampling rate,
wow.
You can monitor all that long waveform and see if there's variations in the waveform pulse width, which you might want for something like interrogate friend or foe type of applications, right, where you have various pulse widths. So it's a great tool for that. One more thing on that is that, so with other types of solutions, when they do long pulse trains, they have to store it in their buffer. And so the buffer fills up fast, and so they can only get about a second worth of waveform length,
right,
which is not very long at all.
Yeah.
So we have a technique called memory buffer mode, where what we do is just capture, we take the whole trace, but then we throw away everything that you don't need and only send back to the customers what they do need. So then the data rate is much slower. So then we can go on for 10 hours or longer. And again, if you're looking for what happens over long periods of time,
Right.
it's a great tool for that. So
Wow.
we're finding customers really embracing that.
Impressive.
And
Thank
one
you.
other application in the aerospace industry is the movement to GaN.
Right.
And GaN, as you know, when we have seen each other at conferences, is one of my favorite topics because the linearity issues caused by thermal. And using our sensor technology, we're able to capture the droop of these sensors, the rise time, and the linearity issues. And now that GaN is moving into the 5G arena, it's even more critical because with the OFDM modulation, what is it doing to the signal at the beginning of the pulse? And you have some thermal characteristics at the end of the pulse. We can actually characterize some of these events nicely with our sensor because of that fast rise time.
And we could also do envelope tracking.
Envelope tracking. Oh, that's another one of my
Another favorite topic. You have a lot of favorite
I
topics.
do. As you gentlemen know, you put up with me, and I thank you very much for doing that.
Well, excellent. You've applied noise analysis and power sensors to such a broad range of topics. You know, a simple solution to a complicated problem. So
Right.
very impressive.
Exactly.
Well, that's the thought process is as these modulation schemes get so complex, test equipment has gotten very complex. I had an engineer back in my early days in 1978 tell me there's only 5 measurements you have to make. And with those 5 measurements, how do you rack them around the instrumentation? So it's nice to apply very simple, basic techniques to a very complicated solution that you can actually get fast results, economical, and products to market.
Yeah, the noise sources are excellent because the alternative is to use a AWGN. And now that people are going to 29, 38 gigahertz, the price for those types of instruments is enormous.
Expensive, right?
But if you can do a much lower cost noise source, it gives you some alternatives and allows you to take those millimeter and microwave frequencies and do things with them at a much more cost-effective rate.
Right.
And that's what's needed really for 5G to go to the mass market, right? We have to bring those microwave frequency, the cost of doing things at microwave frequency down to the 6 gigahertz kind
Right.
of level.
Right.
So it's just having the experience with the microwave for many years, booting over 70 years, Noisecom for many years, and especially at these high frequencies, we fit very well in the 5G from current solutions up in the 700 megahertz all the way up to the 45 gigahertz and beyond.
Very impressive. Thank you very much.
Thank you very much.
you.
It's been my
Matt
pleasure
and
to
Walt.
be a guest.
Thank you.
Thank you very much.
You made my day.
Thanks, guys.
And we thought we'd cover a few of the other products that we saw around here. I was impressed with Amritsu as differential noise measurements now in their portfolio. We saw Keysight, who demonstrated a quantum computing measurement setup, which
Right.
is very far out. And then we also looked at Rohde & Schwarz. They're celebrating 80 years of the invention of the VNA, and they now have converters with up to 14 dBm of output power at 110 gigahertz, so that's impressive. We saw Analog Devices with their new Radioverse product that has 200 megahertz of bandwidth now, so that's impressive. And finally, I saw Synergy had an optical oscillator, extremely low noise. So
Interesting.
quite a wide variety. How about you, Gary?
So we've talked about 5G. We're starting to see some 5G products on the market. There were some devices from P-Semi, Receive LNA with switches, an interesting series of 4 products. And then I saw at the Amplion booth, they actually have for the 3.5 gigahertz 5G band in China, an LDMOS version and a GaN version. And so the customer can take their choice between the higher efficiency or the lower cost options. And so it'll be really interesting to see as 5G deploys how the trade-offs take place. The other thing I saw that was really cool at the IMST booth, they do 3D electromagnetic modeling software. They had a VR headset, and you could actually put it on and go into a multi-layer board with all the surface mount components, and not only kind of walk around the surface, but you could dive into the layers. And it was really cool. The only downside was I was going so fast I was starting to get dizzy. I was afraid I was going to fall over. But that was one of the highlights of the show for me.
Very interesting.
So we want to thank you guys again for coming on Frequency Matters and wish everyone well from the 2018 International Microwave Symposium in Philadelphia.